Welcome to Primary Tutor. Last class we seen the problem on gradient and divergence. In this video we are going to see the problem on curl and various problems related to the solenoid and irrotational. Okay. Our first problem is find the nature of the field that is effector the given and determine divergence and curl. Okay. And also find the nature of the field. Nature of the field means whether the field is solenoid or irrotational. Okay. First we are going to solve divergence. Okay, the given field is effector is equal to 30ax vector plus 2xy ay vector plus 5x z square az vector. So, this function, this effector is a function of x, y and z. So, it is a Cartesian coordinate system. So, okay. So, divergence in Cartesian coordinate system. Divergence of effector is equal to del dot effector. Okay. So, del dot effector is equal to, already we know the del value. So, the del value means dou divided by dou x ax plus dou divided by dou y ay plus dou divided by dou z az. This is the value of del in Cartesian coordinate system. Okay. And then what is the effector? Effector, here the given effector dot effector value 30 ax vector plus 2xy ay vector plus 5x z square az vector. Okay. So, divergence of effector is equal to del dot effector. So, del value is a del value and given effector is that is effector. Okay. Now, going to multiply. Okay. First we multiply the term del into del x into 30. Okay. Already we know ax dot ax is equal to 1. Okay. So, and then plus remaining term, this ax and this ax, if you multiply ax dot ax is equal to 1. Okay. Next, dou divided by dou y term is 2xy and plus dou divided by dou z and then z value here 5x z square. Okay. Now, differentiate this function. So, if you differentiate 30 with respect to x, it become, so del dot effector. If you differentiate 30 with respect to x, it become 0 ax vector plus we differentiate this term 2xy with respect to y, and y become 1. So, 2x ay vector plus next term the 5x z square, differentiate this term with respect to z. If you differentiate z square, it become 2z. So, now, so 10x z az vector. Okay. So, now del dot effector is equal to 2x a vector plus 10x z az vector. Okay. So, now here the divergence exists. Okay. So, this vector not a solenoid vector. Okay. Here divergence exists. So, del dot effector not equal to 0. So, it is not solenoid. This is not solenoid. Okay. Okay. This is the nature of the field. Okay. The given problem is asking to find the nature of the field and also divergence and curl. And first I found a divergence is a divergence value. Here divergence exists. So, this field not a solenoid field. Okay. Next, curl of effector is equal to del cross effector. Okay. So, already we know. Okay, del cross effector it is ax vector, ay vector, az vector, and dou by dou x, and dou by dou y, and dou by and dou z, and the third term is fx and fy and fz. Okay, now substitute the value here. Okay, del cross f vector equal to ax, ay and az vector, dou by dou x, dou by dou y, dou by dou z, and then fx value. That means the magnitude in the x direction here the 30, and magnitude in the y direction here 2xy, and magnitude in z direction 5x square. Okay, now substituted. Now value is substituted, and then take modulus del cross f vector. You take modulus. First say ax, if you eliminate 0, it become dou by dou y into 5x z square minus, if you multiply this term, dou by dou z and 2xy. Okay, 2xy. Okay, minus, okay, and then this minus, then ay term, and then ay time, this remove this column and row, and the remaining multiply this two term, dou by dou x, and then 5x z square minus, then multiply this term, dou by dou z and 30. Okay, then whole term plus az. Okay, if you remove this row and this column and multiply this two term, dou by dou x into, and then 2xy minus, and multiply this term, dou by dou y and 30. Okay, now simplify this term. Here ax vector, I will simplify this term, ax vector, here differentiate this term with respect to y, it becomes 0, and then differentiate this term become, this also becomes 0. Okay, and then minus ay, and differentiate this term with respect to x, it becomes 5z square, and this term becomes 0. Okay, and then plus az, is differentiate this term, it become 2y, and 2y, and this term here 30, here y, so it becomes 0. Okay, minus 0. So final del cross f vector is equal to minus 5z square ay vector. See here, these are the vector. Okay, 5z z square ay vector plus 2y az. It's a final result. See here, the minus y az square and ay vector plus 2y into az vector. So this is the final value of the given function. So here the curl is exist. So this field is not a irrotational. Okay, this function del cross f vector is not equal to 0. So this field is rotational. Okay, here del cross f vector is not equal to 0. So this field is rotational. Okay, finally we obtain the nature of the field and also divergence and curl of the given problem. Okay, our next problem is find the curl of f vector if f vector is some function is given. So now we are going to find the curl of f vector. So curl here now, the curl of f vector that is curl of F vector is equal to del cross F vector. So here the F vector is a function of r, theta and z. So it is a cylindrical coordinate system. Then the formula for del cross F vector is 1 by r a vector and then a phi vector a z vector 1 by r and then dou divided by dou r and then dou divided by dou pi and dou divided by dou z. Okay, here is f of r, f of pi and then f of z. Here r into f pi. Okay, this is the formula of del cross F vector. Now substitute the value of F vector. Okay, del cross F vector is equal to, so now 1 by r and then ar vector and then a pi vector and 1 by r and a z vector. Okay, now dou divided by dou r, dou divided by dou pi, dou divided by dou z. Now substitute magnitude value in r direction. So magnitude value in r direction is 2r cos pi. So now substitute 2r cos pi and then similarly magnitude value in pi direction, so 4r sin phi. Already one r is there, so now 4r square sin phi. Okay, now the value of magnitude value of in the z direction, so 3. Now take modulus del cross F vector is equal to, so first term is 1 by r ar vector into, now eliminate this row and this column and multiply this term, dou divided by dou pi and 3 minus this term dou divided by dou z 4r square sin pi. Okay, and then minus this term a vector pi into, and then eliminate this row and this column. Now multiply dou r, now multiply dou r into 3. Okay, and then this 2 term minus dou divided by dou z 2r cos phi. Okay, 2r cos phi. Now again one more term plus 1 by r a z vector into, so eliminate this row and this column and multiply this 2 term dou divided by dou r into 4r square sin phi. Okay, and then minus multiply this 2 term dou divided by dou pi 2r cos phi. Okay, now going to simplify this term by differentiating each term. Del cross F vector is equal to 1 by r ar vector. Okay, so first term we differentiate this 2 term, first differentiate this term, it becomes 0 and then differentiate this term, here also there is no z term, so this term also 0. So now both the term become 0. Again minus a pi vector into, now differentiate this term, there is no r in this term, so 0. Again differentiate this term also 0, because in this term there is no z, so this field also 0, so this field also 0. Again and plus a z vector. Before taking in differentiation, you should multiply 1 by r with each term. Okay, if you multiply 1 by r with each term, it becomes 4r sin phi and then 2r cos phi. Okay, so now differentiate the 4r sin phi with respect to r, it become 4 4 sin phi. Okay, again minus differentiate this term 2 sin pi, differentiate 2 sin pi with respect to pi, it become minus 2 sin phi. So now final del cross f factor, that is curl of f factor is equal to, this term becomes 0 and this term also 0. So now 6 is signed by az cap. Okay, this is the final curl value of this function. Our third problem is verify whether the vector field, that is this vector field, is both solenoid or irrotational. Okay, so now we are going to verify this vector field is solenoidal and rotational. Okay, first we are going to check the solenoidal case. Solenoidal, that means divergence equal to 0, that means del dot f factor is equal to 0. Okay, this condition is a solenoid. Okay, now we know the del value, del dot f factor is equal to, already we know the del value in Cartesian coordinate system. Okay, rho x ax vector plus dou by dou y ay vector plus dou by dou z az vector into f factor value. Here the f factor value y z ax vector plus x z ay vector plus x y and then a z vector. Okay, now multiply dou by dou x. Okay, now what is the x direction value, y and z plus dou by dou y, the y direction magnitude is x z and plus dou by dou z and y direction magnitude x and y. Okay, now differentiate this function with respect to x. Okay, there is no x term, so this term becomes 0, and then differentiate this term with respect to y, this there is no y term here, this also 0, and similar to this term, in this term there is no z value, so this also becomes 0. So now the del dot f factor, okay, equal to 0. So this field is solenoid. Okay, now we are going to check another irrotational. Okay, next irrotational. Irrotation means curl of vector is equal to 0, that means del cross f factor is equal to 0. So already we know the value of del cross f factor, that is modulus of ax vector, ay vector and az vector, and then dou by dou x, dou by dou y and dou by dou z. Okay, and then magnitude in the x direction, the vector field, here y by z, and then here x by xz, and then y xy. Okay, okay, now del cross f factor. Now take modulus ax vector, eliminate this row and this column, so multiply this term dou by dou y and x and y minus, and next this term dou by dou z and x z. Okay, and then minus this is the whole term. Okay, then minus ay into ay minus ay vector into, and eliminate this column and this row and multiply this two term dou by dou x. Okay, into xy, okay, and then minus, okay, multiply this term dou divided by dou z and y by z, okay, dou divided by dou z into and y z, okay. Now again plus this term a z vector, okay, eliminate this row and this column and multiply this two term dou divided by dou x, dou divided by dou x and x z minus, and this two term multiply this two term dou divided by dou y into y z, okay. Now simplify this term, okay, ax vector. So now differentiate this term with respect to y, it become x minus differentiate this term with respect to z x, okay, plus and similar to this term, sorry, minus ay into differentiate this term with respect to x, it's become y minus, and similar to this also minus y, and then plus az vector into differentiate this term with respect to s, it become z, okay, z minus, so similar to this term, if you differentiate this term is also minus, okay. So finally this value is also 0, this value also 0, and this value also 0, so final result is 0. That means del cross f vector, so that means del cross f vector is equal to 0. So this condition is irrotational. Now the del cross f vector, that is curl of f vector is equal to 0, okay. That means this field is irrotational field or conservative field, okay. In some other question, instead of irrotational they are asking conservative field, okay. Conservative field means del cross f vector is equal to 0, okay. This also this condition is irrotational, okay. This condition is irrotational or conservative field, okay, conservative field, okay, okay. This condition is irrotational field and also conservative field, okay. Now we verified this field is solenoid and irrotational or conservative field, okay. Thank you.